May 31st. Seriously, it is one of the absolute greatest dates in the entire history of mathematics. Welcome to this explainer. I am so excited you're here today because we're going to look at one single calendar date that completely reshaped the way we understand our reality. Let's jump right in. On this exact same day, across completely different centuries and entirely different countries, four brilliant minds changed the modern world we live in today. Moving across our timeline, we're going to meet them one by one. Think of this kind of like a detective story, where the greatest mysteries of the universe actually get solved. 1801, 1907, 1910, 2000. Let's kick things off with a little mystery. Have you ever wondered how the totally chaotic, messy rules of spoken languages can actually be logically organized? I mean, think about the words we're using right now. They seem random, right? Full of slang, weird accents, rules that are constantly evolving. But what if there was a hidden mathematical structure buried inside all of it? Okay, let's dive into this. The answer takes us way back to May 31st, 1801, and a guy named Antoine Meyer. Born in Luxembourg into a pretty modest family, he grew up to become a mathematician with a very unique passion. Meyer pulled off something absolutely massive. He took a mathematician's precision and literally codified an entire spoken language. He applied strict mathematical logic to spoken words and essentially created the very first spelling rules for the Luxembourgish language. And to prove his logical system wasn't just some abstract theory, he actually wrote and published pioneering poetry using those exact rules. He laid the absolute foundation for how we structure linguistics today. And that brings us to this beautiful realization. Every single word we speak is secretly built on a foundation of logical patterns. Language and math, they aren't opposites at all. They are beautifully, inherently connected. We're still on May 31st, but let's jump forward a little over a century on our timeline, from 1801 to 1907. Different era, totally different challenge. Now, you might be wondering about this next one. How do giant airplanes avoid shaking themselves apart when they fly through turbulent, stormy skies? Whenever we take a flight, we just trust those wings to stay perfectly intact, even when the wind is violently hammering against them. How is that physically possible? Now, what's really interesting here is how the answer traces straight back to Herman Arthur John, born in England, May 31st, 1907. He was a scientist who actually started off studying things so unbelievably small, you can't even see them. See, John originally studied quantum mechanics. He was specifically looking at how tiny molecules like methane vibrate and shake. But when World War II broke out, he took this incredibly complex math about vibrating molecules and applied it to a massive, real-world problem, airplane wings. By calculating exactly how to avoid something called wing flutter, he basically solved a highly dangerous aviation problem. It's just wild to think about. The exact same math that holds tiny, invisible molecules together is what keeps our giant airplanes safe up in the clouds. It really shows you just how universal these mathematical laws are. Honestly, the flights we take today are safe because of this work. Same date, but let's bridge our timeline all the way forward to the year 2000. We're going to keep the pace brisk here, jumping from the clouds straight out into the vastness of the cosmos. Have you ever looked up at the night sky and wondered about the empty space between the stars? What if the invisible fabric of the universe actually had a hidden, measurable shape? I know, it sounds straight out of science fiction, right? And this brilliantly illustrates the work of Eric Kaylor, a German mathematician who passed away on, you guessed it, May 31st, 2000. He had this deep, profound connection to both abstract geometry and physics, and he was constantly trying to bring them together. He achieved this by creating something called Kaylor metrics. To put it simply, this is a super powerful mathematical framework used to measure complex, invisible, multi-dimensional spaces. Today, this exact geometry is a fundamental tool that physicists use to map out spacetime and dive into string theory. He essentially handed us the ruler to measure the unmeasurable. Thanks to his work, we know that the universe's deepest, most invisible secrets are written in the language of geometry. It's completely mind-bending to think about, but math actually allows us to see the shape of the universe itself. Let's move back just slightly on our timeline to 1910 and see how this builds into our final mind-bending story for this amazing date. Think about something you've probably seen in everyday life. Have you ever noticed how a horse saddle, or honestly even a potato chip, curves in two completely opposite directions at the exact same time. It bends up at the front and back, but dips down on the sides. How on earth you even begin to measure a twisted shape like that? The person who finally gave us the answer was Nikolai Vladimirovich Efimov, a totally brilliant Russian mathematician born on May 31st, 1910. The guy was insanely dedicated. In fact, he spent 12 long years of his life agonizing over one single, incredibly difficult problem regarding these bizarre shapes. Efimov successfully proved a massive theorem about what we call negative curvature. Compare the two for a second. Positive curvature is easy to imagine, right? It just curves inward like a ball. But negative curvature bends outward in multiple directions all at once, just like that saddle. Efimov gave us the definitive math to finally understand these complex, twisting 3D surfaces without any of the messy singularities. His dedication proved that even the most twisted, backward-bending shapes follow a strict mathematical rule. He found perfect order hiding inside geometry that looks completely chaotic to the naked eye. So the crucial point is this. We've followed 4 brilliant minds today. 4 completely different eras, entirely different countries, but united by one single date, May 31st. Through Meyer, we decoded the messy rules of spoken language. Through John, we secured the wings of modern airplanes. Through Kaylor, we found a way to map the invisible fabric of the universe. And through Efimov, we organized the most twisted 3D shapes. Their individual discoveries collectively built the modern, safe, and connected world we rely on today. Every single person we met in this explainer was ultimately asking the exact same underlying question: what is the pattern hiding inside the chaos? And that is the ultimate unifying thread of mathematics. It's not just about crunching numbers, it's about looking at a messy world and finding the hidden logic. And that leaves us with one final exciting thought. Mathematics is far from finished, guys. It is happening all around us right at this very moment. So what hidden pattern in the world will you be the one to discover next? Keep asking questions, keep looking for the logic, and I will see you in the next